Chat GPT. Maybe you've heard of it.
Now, you may have heard of Chat GPT, and Chat GPT is trained on the internet so it can understand and generate human-like text.
A world where information is king and curiosity is our driving force. What if I told you that the key to unlocking it all lies in the virtual mind of an AI? We live in a paradoxical age, where centuries-old libraries coexist with AI-powered algorithms that can answer any question you throw at them. But how does ChatGPT, generative pre-training transformer, fit into this equation? What secrets hide within the virtual brain of ChatGPT? What are people's burning questions, and what can they expect to discover through this groundbreaking technology? Join us as we dive into the inner mind of ChatGPT. Let's start by delving into the fundamental steps of how ChatGPT operates, then explore its essential AI building blocks that bring it all to life. Taking Google as our analogy. When you request information from Google, you might be aware that it doesn't instantly scour the entire internet for answers. Instead, it searches its database for web pages relevant to your query. In essence, ChatGPT functions similarly. The initial phase, known as pre-training, involves gathering data, while the phase where it interacts with users and provides answers is called inference. The remarkable breakthrough in the popularity of generative AI is due to the remarkable scalability of the pre-training process. This scalability has become achievable thanks to recent advancements in cost-effective hardware and cloud computing technology. Pre-training. In a nutshell, AI pre-training involves two primary methods: supervised and non-supervised. Before the rise of advanced generative AI systems like ChatGPT, supervised pre-training was the norm. Supervised pre-training unfolds when a model is trained using labeled data, connecting each input with a corresponding output. Picture this: an AI learning from a dataset of customer service conversations, where user questions and complaints are matched with appropriate responses from service representatives. For instance, user input like "How can I reset my password?" corresponds to the output: "To reset your password, go to our website's account settings page and follow the procedures." In this approach, the model learns a mapping function to associate inputs with outputs accurately. It's akin to how we teach machines in tasks like classification, regression, and sequence labeling. Yet there are limits to this method. Predicting all possible inputs and outputs becomes impractical and time-consuming, restricting the AI's expertise. This is where ChatGPT stands out. It boasts remarkable versatility, capable of crafting resumes for fictional characters, explaining quantum physics, coding, storytelling, and analyzing past US presidents' governing styles. Anticipating every conceivable question is impossible, making supervised training inadequate. ChatGPT relies on non-supervised pre-training, the game-changing approach. Non-supervised pre-training involves training the model on data with no fixed output associated with each input. Instead, the model grasps the inherent structure and patterns in the input data without a specific task in mind. This technique shines in unsupervised learning tasks, such as grouping data, spotting anomalies, or simplifying complex data. In language modeling, non-supervised pre-training equips the model to grasp the syntax and meaning of natural language. This empowers ChatGPT to generate coherent, meaningful text in various conversational contexts. Here's the magic: the developers don't need to know the precise outputs for each input. They simply feed vast amounts of information into ChatGPT's pre-training mechanism, known as transformer-based language modeling. This process empowers ChatGPT to amass an astounding reservoir of knowledge, enabling it to offer insightful responses across various topics. Transformer architecture. The transformer architecture is a remarkable type of neural network employed in processing natural language data. Imagine a neural network as a hockey team, with each player having a role, passing the puck among teammates to score a goal. Similarly, a neural network processes information through interconnected nodes, mimicking the human brain's functioning. The transformer handles sequences of words using self-attention, a process akin to a reader revisiting a previous sentence or paragraph to comprehend a new word's context in a book. The transformer, however, looks at all words in a sequence, deciphering the context and relationships between them. Comprising multiple layers, each with sublayers, the transformer has two main components: the self-attention layer and the feed-forward layer. The self-attention layer assesses each word's significance in the sequence, while the feed-forward layer applies nonlinear transformations to input data, aiding the transformer in understanding word relationships within a sequence. During training, the transformer receives input data, like a sentence, and predicts an output based on that input. The model's refinement occurs by assessing how well its predictions align with the output. This iterative process equips the transformer with an understanding of word relationships and context, making it a powerful tool for language translation and text generation tasks. However, there is a significant concern about the potential for these algorithms to generate damaging or biased information. These models might inadvertently perpetuate biases present in the training data. Companies implementing these models attempt to establish guardrails to mitigate such issues. Yet, defining these guardrails proves challenging, given the diverse perspectives within society, with one school of thought's bias prevention being labeled as bias by another. Now, let's dive into Chat GPT's data input and user interaction phases. Chat GPT's training data. Chat GPT's training dataset is substantial and built upon the GPT-3 Generative Pre-trained Transformer 3 architecture. A distinction is important here. The free version of ChatGPT is based on CPT-3, while ChatGPT Plus, available for $20 a month, offers the option of GPT-3 or a more extensive GPT-4 dataset. The acronym GPT starts to make sense now. Generative, signifying its ability to produce results, pre-trained, indicating reliance on ingested data, and transformer architecture, which weighs text inputs for context comprehension. GPT-3's training employed WebText-2, a massive 45 terabyte text data repository. Although 45 terabytes may not seem colossal in the era of affordable 16 terabyte hard drives, text data consumes significantly less storage compared to images or videos. This extensive dataset enables ChatGPT to grasp word and phrase patterns at an unprecedented scale, enhancing its ability to generate coherent and contextually relevant responses. ChatGPT, despite being rooted in the GPT-3 architecture, undergoes fine-tuning on a distinct dataset customized for conversational applications. This fine-tuning enables ChatGPT to offer personalized and engaging interactions. For instance, OpenAI introduced Persona Chat, a dataset tailored to train conversational AI models like ChatGPT. Persona Chat consists of over 160,000 dialogues, with participants assigned unique personas describing their backgrounds, interests, and personalities. This allows ChatGPT to generate contextually relevant responses tailored to the conversation. In addition to Persona Chat, various other conversational datasets contribute to ChatGPT's fine-tuning, including the Cornell Movie Dialogues Corpus, Ubuntu Dialogue Corpus, and Daily Dialogue. ChatGPT's training also involves exposure to extensive unstructured internet data, encompassing websites, books, and various textual sources. This broad exposure equips ChatGPT with a broader understanding of language structure and patterns, which can then be fine-tuned for specific tasks such as dialogue management and sentiment analysis. ChatGPT stands as a distinct model with similarities to the GPT series, albeit with differences in architecture and training data. ChatGPT boasts 1.5 billion parameters, a smaller scale compared to GPT-3's 175 billion parameters. The training data for ChatGPT primarily revolves around conversational context, carefully curated to facilitate the generation of natural and engaging responses. Think of ChatGPT's unsupervised training as an exploratory journey through vast data. It absorbs and processes information independently, seeking patterns and coherence. This self-directed learning is the key to the rapid growth of new generative AI systems. While pre-training handles the heavy lifting, ChatGPT must also understand questions and craft responses. This is where the inference phase comes into play, involving natural language processing and dialogue management. Unraveling the world of natural language processing, NLP. Natural language processing, often abbreviated as NLP, revolves around the idea of teaching computers to grasp, decipher, and generate human language. As digital burgeons and natural language interfaces gain traction, NLP emerges as an indispensable technology for countless businesses. The versatility of NLP extends to an array of applications, spanning sentiment analysis, chatbots, speech recognition, and translation. By harnessing NLP, businesses can streamline operations, enhance customer service, and glean valuable insights from customer feedback and social media interactions. However, implementing NLP comes with its own set of challenges, chiefly linked to the intricate and sometimes vague nature of human language. NLP algorithms necessitate training on extensive datasets to discern patterns and acquaint themselves with the subtleties of language. They must remain adaptable, continuously refining and updating to stay attuned to evolving language trends and contextual shifts. NLP operates by dissecting language inputs, such as sentences or paragraphs, into smaller components and scrutinizing their meanings and interconnections to produce valuable insights or formulate responses. Employing an amalgamation of statistical modeling, machine learning, and deep learning techniques, NLP technologies excel at pattern recognition and learning from vast data troves to accurately comprehend and generate language. Mastering the art of dialogue management. You might have noticed that Chat GPT possesses the ability to pose follow-up questions for clarity, understand your needs better, and deliver personalized responses that account for the entire conversation history. This ability enables Chat GPT to engage in multi-turn conversations with users, creating an authentic and engaging interaction. It hinges on the adept use of algorithms and machine learning methods to comprehend and sustain conversation context through multiple exchanges with users. Dialogue management stands as a pivotal facet of natural language processing. It empowers computer programs to engage with individuals conversationally, eschewing the transactional feel of isolated interactions. This conversational approach nurtures trust and engagement with users, ultimately yielding favorable outcomes for both users and organizations implementing the program. While marketers seek to expand the realms of trust building through dialogue management, this domain also harbors potential concerns. It opens the door for AI to potentially manipulate users, a prospect that warrants vigilance in its ethical implementation. Well, that's it for today. If you enjoyed the video, please like, share, and subscribe. We really appreciate your support.